Hi, I'm Steve Hall. Thanks for watching this 17th video in the Veritas series. In the previous video, hope you had a chance to watch that one, number 16, we began to understand what the second law of thermodynamics is all about and how entropy is constantly increasing in the universe. And we pointed out that the way evolutionists get around the problems with the second law is to theorize that, well, given enough time, there could be some monumental exceptions to the second law that would allow life to just spontaneously begin by chance. And we talked about Julian Huxley's illustration that if you had 1,000,000 monkeys typing on 1,000,000 keyboards, that given enough time, say billions and billions of years, one of them would somehow produce a Shakespearean play by sheer chance. Well, that turns out to be fairly easy to check out mathematically. Let's just do that right now. Let's assume we have 1,000,000 monkeys, and they're typing on 1,000,000 keyboards. And let's assume these monkeys are very, very aggressive, and they're typing 24 hours a day, 365 days a year, never stop. And let's assume that the keyboards have 40 keys each. That's a pretty favorable assumption for getting a Shakespearean play out of it by chance. I mean, my keyboard has, I think, 102 keys. So 40 gives us a better chance of getting the play. And let's assume that each monkey types really fast. Let's say as fast as a secretary who can type 100 words per minute. That would be about 500 characters per minute, or 8.33 characters every second. Pretty fast. Okay. How long might we expect it to take for one of them to type one of Shakespeare's plays? Can we figure that out? Let's say Othello. Well, let's start with just the first line of Othello, which happens to be 8 words. Never tell me, I take it much unkindly. The probability of randomly hitting the letter N on a typewriter of 40 keys is 1 out of 40. The probability of hitting an N followed immediately by an E, can you do this one? You probably remember this from your math classes and basic probability, 1/40th times another 1/40th, or 1 out of 1,600. The probability of typing the word never, N-E-V-E-R, that's 5 events, would be 1/40th times 1/40th times 1/40th times 1/40th times 1/40th, or about 1 out of 100 million. So, if you have 1,000,000 monkeys, each typing 8.33 characters per second, they would altogether be typing 8.33 million characters per second. That makes sense. So, with some simple math, we can see that we could expect one of them to type the first word, never, in about 12 seconds. That's 100 million divided by 8.33 million. So you might be saying, oh, I've got it. The first word, 12 seconds. We're on our way. This is no big deal. But not so fast. The math is going to get you. To get the first 5 characters takes 40 to the 5th power divided by 8.33 million seconds. That's what we did a few seconds ago. So in order to get the first 20 characters in spaces, that would get us into the 5th word, first line, would require 40 to the 20th power divided by 8.33 million seconds. Now when you work that out on a calculator, it turns out to be over 13 septillion seconds. That's a 13 followed by 24 zeros, or 400 quadrillion years. Now, secular astronomers and cosmologists have come up with what they believe to be the age of the universe. Do you have any idea what that is? Well, virtually all secular astronomers and cosmologists agree that the universe could have been in existence for no more than maybe 14 billion years max. But in order for the monkeys to type the first 5 words of Othello, they would need 400 quadrillion years. To get the first 5 words, just the first 5 words, forget the whole play, the universe would have to be 20 million times as old as astronomers and cosmologists say it is. But you might be thinking, wait a minute, Steve, wait a minute. We're not talking about Shakespearean plays here. We're talking about the molecules of life. Oh, yes. Now, Julian Huxley's illustration does highlight the mathematical problem, though. I think you can see that. But when you get to the molecules of life, things are going to be much, much worse for evolutionism when it comes to the time required for a living cell to somehow come together by chance. Let's start with the basic building blocks of proteins, amino acids. You may remember from your biology classes that amino acids require the orderly arrangement of about 20 atoms. They're not very large. Proteins, however, that are made up of amino acids, they're far more complex and require the arrangement of literally thousands of atoms. But that wouldn't be enough, because proteins cannot reproduce all by themselves. They can't. So it gets a lot worse. A DNA molecule is several orders of magnitude still more complex. There are 10 billion atoms in a DNA molecule. And when you look at a whole living cell that might be able to reproduce itself, you're requiring the arrangement of something like 1 quadrillion atoms. And that's why back in video number 11, you may remember I compared a living cell to a city. A quadrillion atoms. That's a billion atoms, and a billion atoms, and a billion atoms, a million times over. A million billion atoms. And they all have very specific places to be in that little cell for all the incredible functions of that cell to run smoothly. So if you hear that scientists have set up an experiment like the Miller-Urey experiment, you've probably heard about, you may have been maybe familiar with that one, and they've produced amino acids through chance collisions. Just remember, to get an amino acid, pretty small, 20 atoms, and then to exclaim, aha, now we know how proteins came into existence, and now we know how life itself was produced by chance. It's kind of like giving a million monkeys keyboards, letting them pound away, discovering the word never in there somewhere, and saying, aha, now we know how Shakespeare's plays were written. The age of the universe is many, many orders of magnitude too small to allow us to expect a chance formation of a protein. And remember, we're assuming that all the favorable combinations last until the protein is formed. But here comes that second law of thermodynamics into the picture. Aggravating, isn't it? Even if by sheer chance a polypeptide, which is a chain of amino acids, was able to form on its own, polypeptides do not of themselves get more complex. They tend to break down. These are reversible chemical processes. Energy is dissipated. Entropy increases. Molecules scatter. We cannot expect order to increase by chance. The universal experience of scientists to this effect is formulated in what we call the second law of thermodynamics. The only way that amino acids can be put together into chains of polypeptides and eventually proteins is through an extremely complicated process of engineering design that takes place in a cell and is directed by instructions from the huge library of information that's stored in every DNA molecule of every living cell. Have you by any chance ever watched the Illustra Media video called Unlocking the Mystery of Life? If you haven't, you really ought to see it. You can order the video if you want to, or you can watch it on YouTube. Illustra Media has a playlist of the entire video broken into 12 chapters. And if you begin at chapter 7 in the YouTube video playlist, there's some phenomenal computer animation sequences that will help you visualize this awesome process. If you haven't seen it, I urge you to take time to watch it. In light of all this, Sir Fred Hoyle, the brilliant British astronomer who died in 2001, once wrote this: I don't know how long it's going to be before astronomers generally recognize that the combinatorial arrangement of not even one among the many thousands of biopolymers on which life depends could have been arrived at by natural processes here on the Earth. Astronomers will have a little difficulty in understanding this because they will be assured by biologists that it is not so, the biologists having been assured in their turn by others that it is not so. The others are a group of persons who believe quite openly in mathematical miracles. They advocate the belief that tucked away in nature, outside of normal physics, there's a law you might put that in scare quotes, which performs miracles, provided the miracles are in the aid of biology. This curious situation sits oddly on a profession that for long has been dedicated to coming up with logical explanations of biblical miracles. It is quite otherwise, however, with the modern miracle workers, who are always to be found living, listen, in the twilight fringes of thermodynamics. Remember the Twilight Zone? Hoyle could clearly see the problem, and so have a multitude of other honest scientists. Let me share one more quote with you. This one's from Sir Arthur Stanley Eddington, famous British astronomer, physicist, mathematician from the early part of the 20th century. The law that entropy always increases holds, I think, the supreme position among the laws of nature. If your theory is found to be against the second law of thermodynamics, I can give you no hope. There's nothing for it but to collapse in deepest humiliation. Listen, guys, straightforward and universally recognized laws of physics and mathematics make a powerful statement against the hypothesis of evolutionists concerning the origin and development of life. We just have to do a little clear-headed thinking. We just have to avoid making some really bad conclusions based on terrible assumptions that many scientists make, and of course non-scientists make them too. The second law of thermodynamics gives great glory to our Creator God. So learn to think clearly about these things and stay in the battle.